Pretty excited to be here. I'm going to be that guy that was just mentioned that's going to do a little bit of a deep dive into blockchain itself. Because you've all heard the buzzword. Everyone is kind of sick of the buzzword itself. That's why it gets a little bit of a laugh. But I want to kind of separate the wheat from the chaff here a little bit and explain why it's important, what we can do with it, and really the difference in blockchain technology right now, because a lot of people are being told that it's a big deal, but not exactly what about it is a big deal. So in supply chain, we've been increasingly approached by and sold on blockchain technology as a solution. It's a buzzword and are often not being told the whole story. It's sold as a consulting package in the name of blockchain, but the real underlying technology is kind of hidden from people. So of course, blockchain 101. What is a blockchain? You've probably gotten this lecture a little bit before, so I'll be relatively quick on it. It's essentially just a ledger of transactions that cannot be changed in the past. So why that's important is that everything is secured. The ledger of transactions gets posted to a block. That block is then done, basically. It's verified through all the nodes, through in a public blockchain, through the miners. They compute everything. And then everyone keeps a full copy of the blockchain that's participating in it. So that way, if one person tries to edit something or change the blockchain itself, all of the rest of the nodes that are participating end up kicking that out. So they say that that's invalid because 99.9% of the rest of us say it is not correct. It goes on ad infinitum. So why is that important for logistics and supply chain? It allows for increased visibility and traceability. So you can actually track a much clearer picture of what's going on in your supply chain movements and know that it's a factual picture of it. The security of it, encoded geographic data for cargo, for what's actually on it, what's the bill of lading, the data that belongs with the supply chain. Parity, so an open marketplace is a possibility now. So without having to centralize and come together and take weeks sometimes to book things out. And unification, a single unified environment to build on top of. With blockchains, that becomes a possibility rather than having each company have their own platform that don't really speak to each other. We can now have a single platform layer that does. Similar to how TCP/IP came about in the 80s and really flourished in the 90s. So here's what you won't get told usually. There are three primary consensus mechanisms. Well, first off, what's a consensus mechanism? Consensus mechanism is all of these computers coming together to agree that what is being sent to them is correct. So how is that done? One is the first one everyone's familiar with is with Bitcoin, so that's proof of work. Proof of work means that thousands, millions of computers are calculating very difficult equations in a competition. And the first one to solve it is rewarded. So that's Bitcoin. Once it's actually computed, they come together, they agree, everything's done, it's computed, the first one to get there wins. In proof of stake, that's more of a new and kind of emerging one. Effectively, you are bonding your stake on the network. So an amount of money is put up as a bond, and then the network randomly agrees who is the next validator, the next person to produce a block. And then there's proof of authority, which in many private blockchains is what actually is going on. So proof of authority is, we'll call it HAL for this case. The singular leader of that network approves all the blocks and says this is correct. So it kind of goes against the rest of these models in that it's a centralized authority telling you that, yes, this is correct, rather than a decentralized consensus mechanism. So there's reasons and benefits for each. Proof of work is very secure. It's the most proven. It's validated through the complexity of the calculations and the economic competition that I mentioned. Bitcoin and Ethereum both presently use this, but it requires very specific hardware that can be very expensive and also very energy intensive. Proof of stake is pseudo-random validation. Ethereum 2.0, so it's called Serenity now, is going to be moving towards this proof of stake. There are a couple other systems out there that are validated on proof of stake currently, but it's not as common. It's also not as resource intensive. So while it's not quite the most proven yet, it's not going to be one of those that draws a lot of energy like proof of work. Proof of authority is that single trusted source of information rather than distributed, which currently has increased speed. However, the problems that arise from that is when you have that singular source of information approving everything, what if it's a competitor? If a competitor of yours has to approve all of your data, that's a bit of a problem. So that brings me to private versus public blockchains. And private blockchains, as I mentioned, are not decentralized. Someone or some entity or some consortium of entities controls and owns it. It's a centralized database solution, almost effectively a cloud solution. The owners do have the ability to tamper with that data. It is, however, very fast. And there are problems with competitor data due to the proof of authority validation. Public blockchains, which include like Bitcoin and Ethereum, are decentralized. No singular person or company owns it. As it stands right now, it would take a 51% attack, and Ethereum is moving to a 99% attack would be required to take over the network, effectively making it impossible. It is decentralized. It is a blockchain. It is basically impossible to tamper with. There has not been a single hack of Ethereum itself, for instance. Any sort of hacks that have occurred have been as a result of bad code on a smart contract. It's not quite as fast yet. As the networks move to proof of stake, they will speed up. It's just a natural progression. There are also additional technologies that are coming with, and since blockchain is a very early technology still, from sharding to state channels and layer 2 scaling solutions. It is data agnostic, so whatever you put in it is what you put in it. You don't require certain standards, but that's why it requires companies in the supply chain industry to come together and agree on standards that should be placed under the blockchain. So another scaling solution that's coming about is sidechains, and these are effectively parallel blockchains that run, to the main chain. So they run alongside. They don't have the same validation method necessarily, but they're still openly verifiable, and the sidechain will finally post back that data to the main blockchain itself. And it is true. One of the complaints and one of the concerns we've heard pretty commonly is that executives are afraid of the word public when it comes to your data. There's really nothing to fear. Off-chain storage is one solution that we are actually working with at ShipChain. Storage of documents on the blockchain can be expensive, for instance, but also people fear that they're putting their documents out there permanently, and that's not the case necessarily either. So yes, on a blockchain, it can't be deleted, but no one can read it. But to store a large file, it's very expensive and not the most efficient way of doing it. So you can actually store that off-chain and validate it on the blockchain itself, and I'll get to that in a second. It is encrypted. All of the records on the public blockchain are completely encrypted, and only those with the private key are granted access. So you're not sharing it out there for the world to see, despite the word public kind of being a little intimidating. It is pseudonymous. Wallet addresses are not personally or corporate level identifiable unless claimed. So your company doesn't have to identify which public keys or which wallets actually are theirs. And if it's not enough, because there have been concerns around GDPR, HIPAA, and much more that are significantly more stringent, how do we manage that concern? And that really plays back into one. So what we're doing is a solution called vaults. Vaults are an off-chain method of storage of documents, but are still validated on-chain. So how can we accurately and truthfully know that the document is what it says it is and has not been tampered with at any point in that document's history? Well, providing, for instance, a shipping document is valid without the public knowing what actually was being shipped or on the document itself, the value of the shipment, any sort of identifiable information. Who has it actually? Where is it in the world? Is it on the truck right now? That's a concern and a very valid one. Privacy between transacting parties while still on the public blockchain with security. So the way we're doing it is that the document itself is stored off-chain in your corporate data storage. So you currently have GDPR compliant, HIPAA compliant, FERCA, any of these that exist, compliant storage, and you're encrypting it and it's stored and it matches your corporate data retention policy. So one of the companies we've been working with has a 5-year deletion policy for various reasons. So after 5 years, they eliminate the document entirely. But at the same time, it'd be nice, and they've told us, it'd be nice to have proof that the document itself, even though they don't have it anymore, was never tampered with. So the way we do that is by taking a hash of the document itself. So the hash is a one-way encryption, cannot be decoded. We use another, it's actually a quantum computing proof hash algorithm. So it's a one-way encryption algorithm, and that's posted to the blockchain. So the way we're doing it, you can see that, let's say at block 0 on January 1 at that time, a bill of lading is hashed. And the hash comes out to there. We're using it's called KEKAC 256 to get a little technical. The hash is posted. Nothing changes on January 3rd up to that point. But then on January 6th, let's say that there's a change made to the bill of lading. Let's, an accessorial, something had to be added. Nothing that was, too crazy. But the hash changes. So we can see at that exact point that the document was changed too. And that's important because maybe you didn't mean to make a change to that. Maybe there was someone who had tampered with the document itself. That way you can verify that this isn't the same document. Something happened here at this exact time, so we need to go back to our supplier, our shipper, whoever it may be, that made a change and verify what actually is going on. So it gives you a much more clear picture. So what are some takeaways from this? CIOs and CTOs are flooded with sales pitches on blockchain, and a lot of it, honestly, is not necessarily blockchain itself. So first off, don't fear public. Public blockchain does not mean public data in any way, shape, or form. It means increased security through distributed consensus and validation. Blockchain or cloud, honestly, does what you're doing really benefit from blockchain? It's not a cure-all. It's not going to fix everyone's problems like it's being sold as doing. Does your company benefit from decentralization? Does it benefit from distributed trust and proof of provenance? One of our favorite examples is in food trust, and that's one of the big, emerging blockchain use cases right now. But at the same time, some companies really have no use for it. Does a cloud solution, private, hybrid, or public cloud solution suit you better? And honestly, more open is more secure. Auditability of source, traceability, verification of the source, and still with private control of documentation and compliance to retention policies. Open source is a very important thing. And it's exciting to see more companies move towards that because now you can go in with your team of developers and look at the source code of something and verify, okay, this is what it says it is. There are no backdoors in the software. There's no bugs. We can use this and we can take this and put it into our systems. So having that openness is a very important thing. So I kind of steamrolled through that a bit, but I think that it's important to know the differences in public and private blockchains and really go from there. I appreciate your time. Sure.
We have time for a little Q&A. Any questions? And I'm going to get us started with one because
Sure.
This is where I'm really trying to understand the hype versus the reality. Mm-hmm. You mentioned food integrity.
Right.
So I'll hear companies say, well, this way I can ensure that my food is organic or not contaminated with E. coli or whatever. So walk us through, what can you really ensure and what can you not ensure? Blockchain? Well,
the blockchain is only as good as the data that's put in. So garbage in, garbage out, of course. And that's where IoT really comes in and makes an important play here. One of the things we're working on is having IoT sensors that are verified as truthful posting to the blockchain. So for instance, one of my favorites is refrigerated containers on trucks. So having that thermal data post to the blockchain every so often with time and GPS data, so you can show, okay, nothing actually spoiled in transit necessarily. And you can get more granular with the food trust problem too. I mean, we always talk about the romaine lettuce issue last year where we had to throw out every head of romaine lettuce in the entire country. We'd like to get more granular because we couldn't identify what was going on, where the lettuce came from. You know, it happened all at once. We couldn't really detail it. But now being able to detail that, post to a blockchain and say, okay, this is where it came from, this is what happened.
Okay, great. Other questions? And by the way, you can type them into Slido as well.
Hmm?
Yeah, my question is about the sidechain.
Yeah.
If you could give an example of a private sidechain.
Private
Can you
sidechain?
repeat the question, please, for those other?
Oh, sure. So give an example of a private sidechain. I'm sure they exist, honestly. There are forks of Ethereum that are out there that are private. But so what we're doing is actually a public sidechain. It's validated through what's called delegated proof of stake. So the delegates are voted on by people on the chain. So larger companies would be able to be involved and be validators. Private sidechains, I believe that there are some movement towards having like a hyperledger that links to Ethereum that was just announced even just a few days ago. Is validation based on validity of authority or validity of data?
Oh, that was the one I had, yeah.
Yeah, it's really, that's kind of an interesting one because I don't think it's either. I mean, because you can input bad data into a blockchain. That's just the way it is, similar to a database. I can put garbage in and it doesn't mean anything. The validation, if you're talking about proof of authority, it's based on the authority. Any other validation method or consensus mechanism is just based on the competition or the randomness. How can we believe data permanently committed to a blockchain will forever be secure based on today's level of encryption? Quantum will destroy today's algorithm. That's a good one, actually. And so a lot of different blockchains are working towards quantum-resistant encryption algorithms. So my background being in physics, this is one that's really interesting to me, particularly because as we move forward, we're going to have to move to these different algorithms, and Ethereum is implementing several of these, and I believe Hyperledger is too. We are using quantum-resistant hashing methods that already are there. So it's kind of interesting because we're using methods that are mathematically quantum safe, but there's really no way to know until we kind of hit that edge.
Okay.
Let's see.
So how is the BOL hash example different from a tool like Tripwire, which alerts on hash changes?
I mean, that's a similar example, actually. So it would be just having that public validation there for on the blockchain itself and permanently stored. So that way, if the document is ever deleted, having that validation that the document existed and may have been changed at this time, you can prove that.
Prove that, gotcha. Comment on concerns with GDPR, please.
Certainly. So GDPR is an interesting one because posting data to a blockchain itself, due to the permanence of it, is not necessarily GDPR compliant. There's a couple of solutions to this, one being the off-chain storage vaults, like I mentioned, that we're doing. Another is an interesting technology. It's called ZK Snarks. Interesting name, but it's a zero-knowledge proof that allows for the transaction of data to occur without knowing who the sender is, who the receiver is, or what was sent in the first place. So it's kind of like, let's say you've got a Where's Waldo book in front of you. I know how to find Waldo, you don't. How do I prove that I know where Waldo is without explicitly showing you where Waldo is? Well, a good example would be I can cover up the entire rest of the page except for Waldo himself. I've shown you that I can prove that I know where Waldo is without ever having told you how to find him. So that's an encryption method that's really coming to in itself.
Okay. So do you agree that blockchain won't have widespread adoption across the supply chain industry for 10 years, sort of like everyone will use the hype about RFID 20 years ago?
I think it'll be faster than that, only because of the excitement we've seen around it. But I do agree that it's going to take some time. It's not something that's going to happen overnight. There are going to have to be proofs of concept, pilot programs. A lot of companies are still figuring out how it fits into their technology stack. And that's important because you don't want to just dive into something without knowing. It's still in the exploration phase right now. We are seeing some companies adopt it live, though, and that's very cool to watch.
Okay. And some of these, I don't really understand the significance of the questions, but doesn't ShipChain control or own the efforts of the ShipChain public blockchain?
No, we do not. So ShipChain is fully decentralizing itself. So there's the ShipChain sidechain that will be validated in a proof of stake method that will post to the Ethereum mainnet. So this is a fully public blockchain that we can't control anything on. We have no access to anyone's data. We can't see anything. We can just see that a transaction occurred. It's impossible for us to tamper with anyone's data.
Okay. What other industries are using blockchain other than logistics, and how are they facing the hype versus the reality?
Finance is probably the other, top two example where they're using blockchain. International payment settlement is an interesting use case for it. They're using it behind the scenes. I mean, there's a lot of hype. And honestly, the hype is actually driving a lot of people to get into it and help develop for it. So there's benefits to the hype, but it's trying to weed through it. So international payment settlements are a great example because there's multiple different blockchains that do it. But one of my favorite examples I've always seen is that there was a payment I saw on Ethereum just a couple of weeks ago where one party moved $135 million to another party. It took 30 seconds, it was done on a Sunday, and it cost 6 cents.
Oh, wow.
So imagine having to do that through a wire transfer, all the checks and balances, all the payments, all the time.
Okay, I have to read this one. It's kind of creative. Is blockchain a champagne solution that will be overlooked and ignored by beer budget forwarders and 3PLs? And I also want to ask about the Chardonnay forwarders.
Shouldn't be, because that's what we're trying to avoid. We want to work with everyone, and that's why we've developed what we're calling our transmission API. There are only, at last estimate, 50 to 60,000 blockchain true developers in the entire world, and they're getting gobbled up quickly. We've made an API that anyone can integrate with at any level of development experience that communicates with the blockchain itself without having to know very specialized systems of development. So that way we're trying to reduce the cost and the barrier to entry of blockchain itself.
Okay. In your temperature control example, who validates that this data is correct?
So we know that blockchain can't really exist without third-party oracles involved, without trusted sources of data. So you would be able to identify, and the sensors would post, the sensor companies would post, okay, this is a so-and-so sensor that was tested at this exact time. We can verify that this is a truthful sensor, and then people can make their decisions based on that. So there still has to be real-world interaction. It's not something that's going to be fully automated yet, as much as many people would like.
Okay. So I have a question for you. So I can see a use case for blockchain to ensure that items coming through the process are not counterfeit. Mm-hmm. I would assume that's a pretty good use case, especially in global transactions.
Oh, it definitely is.
Yeah. Is there something in process or mechanism or technology that also allows the prevention of the counterfeiters coming in from another chain? Is there some kind of authentication process that gets built in?
There are several that can be used. So one of which, there's a very basic way of doing it. Let's say you have a very expensive electronic good or a watch or something like that. You can engrave instead of a serial number, engrave a blockchain ID on that, and it can be validated and transferred anytime as a digital certificate of authenticity with whoever you're selling it to. So, for instance, there are things called non-fungible tokens that are out there now, and a single non-fungible token, think of it like a playing card, rather than, if I give you $101 bills, those are fungible. You can't tell the difference between one or another, despite serial numbers. But if I have like a Clayton Kershaw playing card versus a Greg Maddux, baseball card, those are not interchangeable things. And the same can happen with non-fungible tokens. So I can singularly put an NFT, tie it to a physical good, and then as that physical good is transferred, I can also transfer the digital good with it, verifying as a digital certificate of authenticity that it is real.
Great, thank you. Any other questions? Great discussion, that was very helpful. All right, so let's thank John, please, for bringing us some great insights about blockchain.